Sounds good.
Cool. Okay. So after reading through everything, it doesn't seem like it's a ton different from the last 2 weeks. Just a new added element of just comparing two different means. Did it kind of make sense with you guys?
Pretty much.
Yeah.
Okay. The one, I'll bring this up right now before we dive into it. So one thing I could not remember how to do for the life of me, and I didn't have time to go look at it on my own, was how to get a confidence interval with all this, with like the t-score. So we can do that later after we go through part 2, when we get to that part. Because
Well, they have because they have the formula, or you just put everything into the Excel program, or
I could get it through the Excel program. I just for some reason couldn't do it by hand anymore. I don't know what happened. Anyway, we'll do that. We'll work on that when we get to that part in the part 2.
I have the formula, so I can show you.
I think I do too, but for some reason, when I do it by hand and then I compare it with what's on the Excel sheet, it was off.
Hmm.
So,
It may have been the way that you entered it into the Excel sheet too, because I've entered it a couple times and I'm like, wait a minute, what? And I did it by hand, and then I realized
because the null has to be right. Yeah. It's like everything has to be right. Null, 0, or whatever, 95.
Right.
Less, greater, or equal to. It has to be like right for it to. Well, the confidence intervals don't really change too much with those changes, I guess.
Yeah, we'll figure it out once we get there.
Okay.
Do you want to just jump into part 2, because part 1 was just kind of basic questions about the lesson?
Sounds good to me.
Okay. So part 2, question 3. What is the research question? Just pretty much, will the new program or new procedure that he implements make the workers faster at completing 100 products?
That's what I put.
Yep. Same thing.
So the null hypothesis equals 0. And then the alternative is if it's less than 0. Is that right?
Well, no, it's not. But that's funny because that's what I thought too. And it wasn't. It was if it's equal 0. Or, I mean, if it's not equal to 0. And I was like, where, at what part in the reading did I just think, oh, it's less than? And so I was reading through, and it says, I don't know. It said somewhere in here, there was something that triggered like the whole less than thing.
Oh, I got it.
It feels like the amount of time that his workers are spending in part of somebody is too long. And so I'm thinking automatically, okay, well, then he wants it to be shorter. But I thought less than, but when I looked at it again, in the end, it's like he wants to know if the mean assembly time is different.
Okay, so he just wants to know. Okay.
Right. So it's go ahead. Sorry.
I believe that's half right, like that it's less than, but you could also say greater than. So rather than writing less than and greater than on there, then they just say not equal to 0, which, so.
Yep. That makes sense.
Right.
Okay, number 4, collect the data. I think we've all probably done that. Describe the data. The key were the key points. So I got for the mean I got 1.056.
Mm-hmm.
The standard deviation 2.596. Obviously n equals 9.
What? I thought it meant it was 6.
Nice. Just flip it upside down. Okay, so there's all the special data. What? Blah, blah, blah. What type of hypothesis test is appropriate? The one we're doing. What is it asking for on these ones? I don't even know.
Like-
go ahead.
No, you go ahead.
No, you go ahead.
No, you go ahead.
Okay, so I was like, huh? And then it was just basically, is it two-tailed? Is it left-tailed? Is it right-tailed? That was it. So, like it'd be two-tailed. So that's basically what. Yeah, like they just wanted to know, since it's, since the hypothesis is equal to 0 or then not equal two-tailed, and so.
That makes it two-tailed. Okay, got it. Requirements has to be normal, all that good stuff. C compute.
So I tend.
What's up?
Sorry, for the B, make inferences on B. I realize that I tend to struggle sometimes, where it's like, okay, because it's like, oh, the sample mean of differences comes from a normal distribution, and we assume the random sample of the population. So it's like normal distribution and random sample from population. But at the same time, in other lessons, it goes, well, we don't really have that data, and technically this is small, whatever, but so we're just going to go ahead and assume. It's like you don't really get the data,
Yeah,
and because it's not a large sample size.
The lesson we just read, it was like, technically it's not a large enough sample size, but we're just going to like do it anyway.
Right, so that throws me off. I'm like, well, how do I know to do that next time? Like if there's another problem like that.
Yeah, that was kind of weird.
I think they just want to make us do it because they want to laugh.
Right.
Someone's laughing somewhere.
All right, part C, compute the difference between the two times and determine if the requirements are met for this test. So let's see, a simple random sample of population. So I think this is where that comes in, because I just looked at the answers to see it's because it is a simple random sample, but n is less than 30. So it says we need to make a QQ plot to see if it's normally distributed, and
right.
it is. So I think
Which it doesn't, like, to me, I'm like, how is that normally distributed? Because the dots are.
Well, no QQ plot that you have in the entire world, if you ever do like any kind of test, will be perfectly straight line. But as long as you have some kind of form that it's going in that direction, then
like it's not going this way and then one's way up here, one's right down there.
Right, because I mean it's all kind of going that direction. If you had like one way over here or way down on the bottom, then you would have some issues.
Okay.
But for the most part, all of the data is in the same area and going in the same direction. So it's really weird, honestly, but
the answer even says the differences may not be normally distributed. It is hard to tell with so few samples. It's like, what? So they might not even be normal.
Right, and you're like, wait, what?
Yeah,
that's
what I'm saying.
All right, so part D, continue the test regardless of what you found in part C, compute the test statistic. Found that to be 1.22.
Which is what I got, but it's funny because when I check the answers, it says 1.22 or negative 1.22. And I was like, oh, well, duh. Sorry,
Yeah,
I don't know why that just clicked
it's
now.
the same as the z-square, yeah.
Right. I'm sorry. Two-tailed.
It's okay.
So degrees of freedom is n minus 1, 8. Compute the p-value to the alpha level. I don't know. What did the alpha level mean? I don't remember.
Alpha is also the area or the probability at the top of the
normal curve probability thing.
The normality, yeah, but it's not, yeah. So that's what the p-value.
Okay.
And I guess when I say alpha level, does that mean where if it says like 2 point something and then times 10 or like 0 to the 10th power or something,
I have no
and
idea.
then they want you to put it into decimal form? I don't know.
I just thought that it meant that you have, like it's normally what we do anyways, but it just like added on that term and made it seem confusing because it was like you do the p-value, but then,
Right.
like it threw me off at first what that was, and I was like, how do you?
Yeah, I didn't know what he was asking there until I just like ignored that part.
Yeah, and then I got the right answer, so I don't know what I did.
There you go. All right, let's keep going then. So let's see. Is there a way to calculate the p-value by hand, or is it just on the Excel sheet?
Yeah, you can calculate it by hand. If you go to lesson 10, I believe, in the textbook, or
Okay.
11, it has the equation there. I should know it
Yeah, no,
offhand.
I need to have a list of all these equations. I keep forgetting.
Yeah, me too.
I thought I had it written down somewhere.
I think it's in lesson 10.
Oh, ugh. Yeah.
Yeah, it's lesson 10. Let's see. P-value, where are you?
It's
maybe not.
I would say no, it's in there. Otherwise I wouldn't have this written down.
In your section 10 notes, right?
Yeah, because I have this is 10.
Yeah, that's where all my calculations are, so I don't know.
Right.
Oh, wait a minute. What?
No, maybe it's in 9. Hold on.
I'm sorry, that may not be the right equation. Okay, forget that I showed you that.
I didn't see it. What was it? Show one more time.
Oh, got it. So it is in lesson 9,
Okay.
and the p-value is, you use the applet to find what it is. So I don't think you can do it by hand.
Okay.
I think never mind. I'm not going to think too hard on that part.
Because basically you put in the t-score or the z-score or whatever you're using in the applet, and then you figure it out that way. Because if you did it by hand, then it would be like, whoa.
Yeah.
Like, could we like edit out that part where I showed my paper for 10 seconds there?
I just figured it out. I had the wrong pieces highlighted on the graph. You put the t-scores in, and then you select the two tails.
Right, just the outside two tails.
Yeah, I had the middle part selected, so it was.
Oh, so it was all funky, and you're like, what? Yeah.
Okay. Cool. Got it. 8 to make a decision. So the p-value is 0.257, which is greater than our whatever it's called, confidence. So you reject.
We failed to reject.
Failed to reject
the null hypothesis.
Cool.
We have insufficient evidence, as they say.
Yes.
I'm like, there's no sufficient evidence to show.
That works too. So 6i, rather than testing a hypothesis, now say you just wanted to estimate the mean difference between weight times 95% level. What would you do? Be sure to calculate the margin of error. Do it and paste your results below. So we just use a 95% confidence interval using the t-distribution.
Right.
And then this was really weird, like, and I didn't really get it on the answer thing was different from what I did, so maybe I did something wrong, but I'm going to read what it says on the answer sheet. It says negative, I see. Okay, never mind. It has two different answers, so you have the high and low of one option and the high and low of another option.
So the teacher put out a little video on this. Did you guys happen to see it?
No.
Okay, so basically this problem was on lesson 11, number 1, margin of error. And it threw me off because I was like, what? Because I don't know why. I was trying so hard to figure it out, and I was thinking probably way too hard on it. But I got that one wrong twice. So then he put the video out, and I was like, oh, that's easy. Like, and it was basically what I had did a while ago when we had to kind of work backwards when we were discussing that all. And I said, well, you know, take the confidence interval, subtract one from the other, and then like divide by or whatever. But no, he was just like, you know, you just take your confidence intervals, the negative 0.9397 minus 3.0508, and then you get like negative 3 point something something something, because you're basically saying negative minus another number, so it's going to be a higher negative number, and then you divide that by 2, and then that's your margin of error. So it's actually like, I don't know, when he did the video, I was like, oh, that was easy.
Yeah, I have to see it too.
Yeah.
Well, because then I checked it out too. Like I just did it. Because the margin of error was 1.996. And so I took 3.0508 minus negative 9397. Oh, no. And it was like 3.9905 divided by 2, 1.99525, so 1.996. So it's basically just doing that and then divided by 2, and that's your margin of error. So I felt like it was almost like they showed us this in lesson 12, but yet the question was on the lesson 11 homework. Unless I missed something and I didn't know. But
Yeah.
does that make sense?
I'll have to go watch that video because it's still not really making sense to me.
Oh, he just says take this, you know, subtract this from this and then divide by 2. That's your margin of error.
That's it.
Like that's it. So
Okay.
Anyway.
I have to look it up. All right. We're 7. Probably don't need to do anything. There shouldn't be action because it would make a difference.
Well, it's like do nothing, or they can just try another type of whatever method, or change something again and then retest it. So.
Right.
Yeah, because he didn't end up shortening the time, and that's what his goal was. And so obviously he needs to change his tactics somehow to accomplish that.
Right.
Yeah. Alrighty.
With the quiz?
Yep.
All right.
Do it.
There are 19 questions.
Oh no.
Come on.
I know, they kill us with these. At least the homework ones that we do by ourselves are shorter.
Yeah.
It doesn't look like it's very fun either. I guess it's pretty straightforward, though. We don't have to read this whole story paragraph about what. I'm on number 3.
Okay. Okay, T distribution applet and the chapter 12 data. All right. Oh my gosh, it's a lot of stuff.
Yeah.
All right. Okay.
Here we go. Let's dive in.
Number 3, what's the value of the test statistic? Well, I'm going to just
All right, let's.
get the information here. Okay, so there's an A1 and a B1.
A1 and a B1?
Oh, those are the first and the second. Sorry, that's the comparison, the difference. Chapter 12, 1, A1.
Hold on, I'm confused.
So we're going to take. Okay, I guess I'm thinking.
We
Huh?
don't need to use the data files, right?
Are you
for this.
sure?
I don't think so.
Well, okay, so the value of the test statistic. So they're asking what the T value is?
Yes. So we just do 2.2 times by, or oh, hold on, gotta get my formula straight. 2.2 divided by the standard deviation, 3.3 divided by the square root of n, 9. Yeah, we don't have to use the data files for this one. I think those might be for later.
Hold on a sec. I left my notebook with my calculations.
Okay, so the value of the test statistic.
I got 2.
D equals X after, and X before. What?
Just
Okay.
go
How
through all that stuff.
Well, I know, but what did you do to get 2? Because there's a one sample T and there's a paired sample for T. Oh, because we don't have the X, so we would have to. Okay, so probably the pair sample. Okay.
You just use the mean, which is the mean of the
Well,
difference.
wouldn't it be D minus 0?
Yeah.
Over.
Yeah. So D minus 0. Divided by the standard deviation, so 3.3 divided by the square root of 9.
Ow.
That makes sense.
Yeah.
Did you guys get 2 as well? I want to make sure
I got 2.
Sorry, what question are you guys on?
on 3.
We're on 7. We're on 7.
Jerk.
Hey, no name calling. I'm
Okay.
offended.
You're
Just kidding.
you're
I'm
really nice.
I'm totally just kidding. I'm really
You were
laid
just
back.
teasing me. And
I know.
so what's the equation for t again?
It's d. What is it? So the mean of b. So the mean of the differences minus
0.
0
Why is
divided
it-
by the standard deviation divided by the square root of n.
Oh, that's right. Why is it minus 0?
Because
Because, go ahead.
go for it, Susie.
Because you're doing it's a paired sample equation for t. And because you're kind of,
You're like comparing it to 0 because the null hypothesis is 0. I think that's how I understood it. It didn't make a ton of sense to me.
right.
I just noticed that it was always 0.
They just want to know if the information they get will be different from what they have. So they're basically just taking the mean difference minus from 0 because they don't really have a value yet. But so that's what they're trying to do, is trying to get what would be the value, or what would it be different than what they have.
Okay.
And so they're just going off of 0. Excuse me.
That makes sense.
Yeah.
And I got 2 as well. So
All right, cool. All right, number 4, the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. You use this probability to determine the p-value for Jordan's hypothesis test. Okay.
So basically we plug in 0.0403 as our test statistic, so as our t, and then we use that same equation. No, wait, stop. Oh, we just use that as our test statistic, and then we plug it into the applet thing.
0.0403.
Whoa. So then would this be a two-tailed?
Yes.
Yeah.
So then it would be 97.9704, right?
That's what I got. In the students, the t probability, not the.
Oh, wait a minute. I got to change the degrees of freedom.
I got 0.9.
Wait. What? You have to change the degrees of freedom?
Yeah,
What am I missing here?
it makes a big difference too, because it sounded like, Josh, you got 0.9691.
0.9688.
0.9688.
Where am I? Holy cow. Yeah, 0.9691. Wait a minute. No,
Is that what you guys got?
Nope. I'm
No.
taking back my answer.
The t, it for some reason it changes the t, so you have to go back and change the t again after you've changed the degrees of freedom.
What? Okay, I got 0.9688.
Yeah.
Perfect. That's what I got. What do we round to? 3 decimal places, so 0.969.
Mm-hmm. Use the data file, chapter 12, data a1.xlsx.
Yes, I have it in already.
Hold
Okay.
on. For the p-value, do you highlight the middle or the two outside parts?
The two outsides, because it's two-tailed.
Okay.
Yeah.
Okay, just checking.
Wait a minute. Hold on. The probability of obtaining a test statistic greater than Jordan's test statistic.
Oh, that changes things.
Oh.
So we would need to go back, and it wouldn't be two-tailed. It would
It needs to be greater. It'd be the right.
It'd be the right and the middle. or
yes.
the left side and the middle. So we would actually be at 0.4904. That's what you guys got. Wait, let me go back and make sure that the 0.0403.
I got, so the left side and the middle, I got 0.5156.
Yeah.
Huh. Not letting me highlight.
The middle one is
my
really,
highlight.
it's tiny.
Well, no, I had it highlighted and then it undid it. Okay.
Huh.
What did you get again?
0.5156.
Okay. So 0.516.
Yeah.
Nice catch.
Yeah, that saved us. Good job.
.516.
Okay.
All right.
Now we get to use the data files.
Okay. Perform paired sample t-test and blah, blah, blah. Be sure that the test group does 1 minus group 2. Use a null hypothesis of equals 0 does not equal, 10. That's a game changer. So it would be 90, confidence level of 90.
Yes. Let's change that now. Null hypothesis is 0 and type of test is not equal to 0. Is that right?
Correct.
Okay.
So what is the t value? I got 3.737.
I got something different.
Oh, okay. Well, let's figure that out. What's in your confidence level? Yeah.
0.9.
Okay.
got-
Let's see.
I got 0.407. What's your mean for the differences?
To take group 1 minus group 2. Okay.
So
My mean is 25.591.
So I got 31.025.
Oh, hold up. Wait, no, that's fine. What?
Group 1 minus group 2, right?
Right. So it's not 12 data. It's not 12 data like. Oh, I see what I did there. When I downloaded both of them, and the B, like here's A, and then the B came in and pushed it over.
Nice.
So then I clicked on B. That's why. I had the wrong one.
All right, let me know what you get once you get those ones in there.
Okay. Uh-oh. All right, let's see. All right. What did you get for your t value?
0.407.
Great, that's what I have.
Cool.
So I've had to do everything manually because I'm not very good at Excel.
Oh my gosh. Josh
yeah.
told me a little trick and it's like saved me so much pain.
What is it?
Josh. Oh.
So here, do you want to know the quick way to do it?
Yes.
If you just do the first one, so go to like cell, I'm sure you've already done some of the manual math already, but just go to cell C2. You know,
Okay.
I'll so that you can see it. That'll probably be faster. No.
If you click on the top number and hit Shift Control and then the down arrow, it highlights the whole list of numbers.
So can you
And
see
then
my,
you copy and paste it
can you see
over.
my Excel sheet there?
Yes.
Okay, so I'll just go to C2, hit equals. You click on, hit minus that one there, and then press enter. And then you can just drag this down, so you can go to the right corner, so that's like a little plus sign. And if you drag this down, it does them all automatically. Does that make sense?
A little bit.
If you just click on your top number, like go to group 1, click on the top one and hit Shift Control down arrow, it highlights the whole section, and then you just copy and paste it. Then just click on the next empty slot, like where you want to paste it. Click on just that top slot and then paste it, and then it'll put all the numbers in.
Okay, maybe I'm not hitting the right one because it's not doing it.
Okay.
Oh, unless, are you on a Mac or a PC?
I'm on a Mac.
Okay, I don't know.
I don't know how that works.
Yeah, it's a little bit different. So.
Would it be different if you just hit Shift Control down?
Well, that's what I tried, but then it zoomed me out of my screen, so I don't think it's the same thing.
Huh.
Yeah.
That probably won't be the same thing. Did you get the equation down though?
If I can do so for equation wise, I can just press C2, and then I can write A2 minus. Oops.
No, so you have to put an equal sign in front of it, or else it won't be an equation.
Okay, it's asking for average, but we'll do.
Yeah, I don't know how Macs work. Macs are weird.
Count. Well, I don't even know how to do it on a PC either. It's the weird thing.
You want to share see if you can share your Excel sheet, and maybe we can figure out how to do it.
I'll do that.
Because that could definitely take a while.
Yeah, it did on the homework. I was killing myself.
Okay, so just while you're in there, so hit the equal sign, and then click on A2, and then hit minus, and then click on, there you go, now press enter. Cool, and then highlight that, and then if you just double click right now, when it's a plus sign, oh, sorry, go back, so press enter. So click on the cell again, and then when it's a black plus sign, so move it over the little square on the bottom right corner. Double click, or just drag down. Yeah, that works. Bam.
Cool. Nice. Awesome. Cool.
So now you can copy all that stuff to the whatever the other Excel sheet, and you don't need to do all that other stuff at the bottom.
Okay. Yeah, because I was doing like the mean and all the. So
Mean minus the mean, yeah.
Okay, so I'm
Okay.
on 9, but I'll go back to what, 6?
So there was an actual Excel sheet that you guys used too that kind of like had all this already on it. That did the math for you.
What's
Yeah.
no? Well, it's that same quantitative inference pro whatever thing.
Oh, it's the same one. Oh, okay.
Yeah. But there's a tab at the very bottom. So there's the one sample t-test. If you go to the paired sample t-test at the bottom, there's another tab that has like all 3 columns already in there. So you just paste all 3 columns, and then it gives you everything from there.
Okay, cool. All right, that makes it a lot easier.
Yeah.
At least I know how to do it the long way. I mean, part of the way.
That's right.
Sorry.
That's okay. We all gotta get on the same page.
Totally fine. Totally fine.
Were you able to find that quantitative inference sheet?
Yeah, I'm on it right now.
Okay, cool.
Well, I'm on the quantitative inference procedures sheet.
Mhm.
So, and then I just use the 2 sample t-tests.
The paired sample t-test.
Oh, it's a paired sample t-test. Oh, that's where the differences would be then. Okay. Great.
Yeah. So then you can just paste all 3 columns in there, and ta-da!
Okay, you guys can go ahead without me, and I'll just catch up to you.
That's okay. I can't remember what number 7 was, Susie.
It
Is it
is.
fail to reject? Because
Well,
it's
we did 5, which was 0.407, and then 6 is what is the p-value, and that was 0.689,
yeah.
and then 7.
So the p-value is
Well, because the p-value was higher than the 0.10, so that was a fail to reject the null hypothesis.
okay.
And then
Perfect. Just double checking on that one.
Okay.
Suppose your alternatives.
So then for number 8, I just changed it to not equal to greater.
Okay.
And so when I did that, the p-value went down, but it was still higher than 0.1.
Yes.
0.3. And so I had to kind of, I was like, huh? I had to read. But so it would say we have insufficient evidence that the mean of the differences is greater than 0. Because we're still failing to reject the null hypothesis.
Right.
So like you tell me if you think that's right.
I think that's right. Correct decision. Yep, that sounds definitely right to me.
Okay. And then I was gonna get ready to do the chapter 12, but I thought I'm gonna wait. Or I mean number 9.
So I got 0.407 for the t-score, the t-value.
Good job.
And then I'm looking at the p-value now for number 6. Wait, yeah. And basically I just plug that in onto our little applet here.
So it has it on that quantitative sheet. It has it at the bottom.
Oh,
Which
it
is
already
right.
has. Okay, so 0.688 then.
Yeah.
Point
If you round it,
689.
yeah, 689.
What is the correct decision based on this evidence? And that is reject the null hypothesis.
You want to fail to reject it because it's higher than the.
That's right. It's flipped around. I always get that.
I know, right? Definitely.
Okay, so since it's higher than 0.1, then that means okay. Okay, and 8. Suppose your alternative hypothesis is instead. What is the correct decision based on this evidence? So then basically that's like saying we're flipping it over.
And that was a little tricky. So you don't have enough evidence to say that this is greater than. So it's insufficient evidence to say it's greater than. So like the second one?
Yeah.
Okay.
Okay. Perfect. Okay, now on to 12. Or to chapter 9, but the other, yeah. You know what I mean.
Interesting.
Yeah.
Oh. 0.01? Oh. So that's
Yeah, so 0.99 confidence interval. Null hypothesis is 0. Test is not equal to.
all right. Oh my gosh. You really don't need all the information from the chapter data for number 9.
Yeah, number 9 is easy.
I was like, I gotta get all the information and
Helps with the
That's
rest
funny.
of them though.
That's funny.
p-value. Ooh. 0.001.
That's what I got for you.
Good. What decision do you make? Well, 0.001 is less than
Less than. So we
0.01. So that means we reject null
Correct.
hypothesis. You decide. Okay, this time you use greater than. Ooh, wow. 0.001 for rounding up.
the p-value.
And you keep the same level of significance. Did the p-value increase or decrease? Well, it decreased, but if you round it up, it'll go.
Well, it decreased. If you're looking at the whole value, it decreased.
That's what I'm saying. It decreased.
Yeah.
Okay.
We still reject it.
Yeah. Yes, you would.
Nothing changes there.
Okay. So I would say we have sufficient evidence that there is a mean difference between the two groups.
Yes, that's what I was looking at too.
Okay. Jake, where are you at?
I'm with
Are you
you.
with us? Okay.
Yeah, no, I got up and I'm getting everything out. So once I figured out how to do that Excel, whew, man, it's helping me loads. So
Good.
Oh,
Okay. 15. The p-value depends on alternative hypothesis in general. Oh. Which alternative hypothesis will give the smallest p-value? Oh. Hold up.
It's got to be greater than.
yeah, it's greater than.
So then what does, I'm just going to check something here. Less than.
If you make it,
Oh.
it makes yeah.
I went way opposite.
I did the same thing.
Yeah. Greater than. Mean is greater than 0. Okay. Determine, oh. Okay, guys. Determine the 95% confidence interval for the mean difference between the two groups. So does that mean we want to change the confidence level to 95?
It's already at 95, or mine
Well,
was already there.
it's supposed to be 99.
I don't
Oh, it
think
was supposed to be 99.
Wait.
Wait, you should have it at 95 if you're going to do this question.
Yeah.
Right. I'm saying before I had it at 99 and now we're at 95.
Oh.
Okay, so what is the point estimate for this 95 confidence level?
Wait, so if you did it at 99, ooh,
Hold on. Point estimate.
that didn't really change anything.
That's X. What is the point estimate for this 95 confidence interval? So the point estimate is basically the X.
Right. So it's the mean, right? And the mean of the differences.
That's what it should be.
So 11.955. Does that sound right?
Hold on.
Oh, wait.
Yeah, sample means. Oh gosh.
Wait,
I
what
guess
did you get, Josh?
that's what I would.
Well, yeah, 11.955, which is
Right.
so
Your confidence level is at 95. Is the type of test, is that equal to, or is that still
it doesn't change the mean or anything.
okay?
It doesn't change the mean or the confidence interval, so I don't think it matters. So do we just put 12? Do we round up to the next whole number?
Oh, does it say?
Doesn't say anything about rounding.
Wait, hold on a second. I need to go over this again.
Yeah, I need to review what a point estimate is.
Well, because it said, I
Okay.
wrote down the little codes. X equals sample means and point estimate. T equals critical value with n minus 1 df. S is sample standard deviation and the sample size. So that's my little book. I guess that's where X sample means. So I guess, because that's what I would think of doing, and that's what I would think then to look at the sample means.
So a point estimate.
So it is that in that little graph, when we were introduced to point estimates, then it showed what was equal to what, and the X with the line over it is our mean, right?
Right.
And so that's basically the same thing, or it's the point estimate for what we're looking for.
So it's 11.955.
Yeah, so Josh, you were right.
Okay.
Yeah, Josh, you were right.
That one I'm not very confident about.
Ooh,
But
margin of error.
But are we, where does it say we're supposed to round to that?
I don't know.
Is it one of those tricky things again? Okay. Margin of error.
I think it's just a whole number.
Does it say whole number?
Yeah, so 12. It doesn't say it, but
Okay.
So for the margin of error, I took one confidence interval, subtracted from the other.
Right.
5.303 minus 18.607,
Mm-hmm.
and I got 6.652 negative, or
Wait, what? I got
I got-
13.
what? You have to divide by 2.
yeah,
Oh, I didn't divide by 2, sorry.
6.652.
Yeah. So
How do we?
why is it
Whoa.
why is it giving me a negative though? That's why I'm.
It shouldn't be negative.
Oh well, because you don't have. Well, if I go 18 minus 5, it's not negative. If I go 5 minus 18, it's negative. But I don't know. Does it
I
matter?
think it's just positive.
Yeah, because the margin of error, it's impossible for it to be negative to go backwards. The margin just represents
Yeah.
the point A from point B.
yeah.
So it can't ever
Okay.
be a negative number.
That's true. That's true.
Yeah, that always tricked me a lot. But on this one, do we round to a whole number or do we round to the first 3 decimals?
I would do the 3. It's in the top. In the top, it says round to 3 decimals unless otherwise noted. Right?
I'm pretty sure that's like a general rule.
Yeah.
But that's weird because on your maybe I'm not seeing it for number 16.
For number 16, well, let's do 3 decimal places for 16 because that's
Yeah.
Because it doesn't say anywhere where we need to do full numbers.
But you towards the in the beginning.
In the beginning, what?
It says do not round until yeah, when calculating anything, please remember to round to 3 decimal places unless otherwise specified. So if they don't specify it, then
Right.
it's automatic 3.
so 16 is 11.956 and 17 is 6.652. Right?
1.956.
Mm-hmm.
Okay.
I totally put 955. Good job, Josh. Saying that. Okay. 18. Input the lower bound around to 3 decimal places. So 5.303.
Is that the full number though?
That's what the Excel.
Because on the mean, you guys put the 11.955, but my computer doesn't show any numbers after that because we said 11.956.
Oh,
I guess you're right.
no, that's true.
So is it 11.955 and then there's decimals after that, or is
I'm gonna say 0.955.
Yeah,
That's
2955.
all it gives me. Oh my gosh. Good job, Jake, on that.
I was like, I don't know if because I have a Mac, I'm seeing different things, or
Yeah. I just, for some reason, I saw the 5s and I was just like, I'm just
you're
assuming
like,
it's
oh,
5.
6. Yeah.
Yeah.
Okay. And then the upper bound, that's easy. 18.607. Okay, I'm going to submit it. I'll be the guinea pig again.
Okay.
Don't joke, okay? Don't be like, oh, we got 3 wrong. Just kidding.
I've only done that once. Okay, let's see. We got a 90%, so we missed 15 and 4.
Oh, really? All right, let's take a look.
Wait, what did you guys put for number 4?
0.516.
Okay, I got the same one. Then yeah, we all got it incorrect.
That one's weird. let's do 15 first, and then let's go back to 14. Number 4.
Okay.
Okay, so for number 15, the p-value depends on alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value? Well, so then would we say not enough information? Depends on the problem?
I don't know.
Because we know greater than will give us the smallest p-value, but that was the wrong answer. So I think that it would be maybe not enough information.
So wait a
We're gonna have
minute.
a random.
Huh?
On your guys's,
Data. Go ahead, Jake.
you did put the mean, and then it's going toward the mean, so that signifies greater than 0. The last one. You guys selected the fourth one, right?
Oh. So which one did you click on? Okay, this was four there. Which one did you click on?
That's the one I clicked on, the last one.
Yeah.
The last one, which is what
Yeah.
I had too.
Okay,
Yep.
I'm just making sure that we did the same one, because I know that that's what that means. I just...
Yeah. No, that's right.
Okay, all right.
Oh, wait a minute. But hold on.
So
wouldn't the alternative need to be greater than the mean?
Hypothesis.
greater than the mean.
Oh, wait. No, that's right.
We reversed it then, huh?
Yeah.
Hold on.
Wait. U is bigger than 0. So for 12, has U bigger than 0, and it decreased. But that 12 was right. So
Yeah, that.
only thing I could say is it would just be not enough information. Depends on the problem.
Yeah.
So I guess I kind of want to stick with that.
Okay, try it, and then we'll see.
Okay, well, let's go to number 4 here.
Yep.
Let's see. Oh gosh, the probability of obtaining a test greater than Jordan's test is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
It's such a strangely worded question. So let's.
And the answer we put was 0.516, right?
So the probability of obtaining a test statistics greater than Jordan's, which is we determined Jordan's test statistic is 2.
Well, see, so the test statistic it's saying is already, the probability is already greater than Jordan. What? 0.5? But it's not equal to. Oh, you know what? Because we did greater than in the applet. So do we just need to do a two-tailed or not equal to?
Hmm.
I just need to read the question about 1,000 times so I can figure out what it's asking.
Okay.
Oh.
What's up? What'd you?
It's so obvious.
What?
Sorry. You select the right side only, not the center or the left, the right side. So basically you take our answer that we put and you subtract it from 1, which is what the other side is. Does that make sense?
Yeah.
Okay, hold on. So
Let's
that's
see.
So point
Yep, that would make
four,
sense.
484.
So 0.485.
No, 0.484.
But it says 0.4845.
Mine says 0.4844.
Yeah, I have 0.8444.
0.0403. Let's take a look.
Your degrees of freedom.
0.484. Okay. No,
Yeah.
I re-input.
That makes sense. Because I was like, why is this not working? I know we're doing something. We just had to select everything that's greater than. We were selecting everything that was equal to or less than.
Right. No.
Okay, I'm test dummy number 2. I'm going for it.
Okay,
Okay.
good luck.
All right, well, we got 15 right, but 4 is
What?
Oh, what?
Wait. One more time. Oh, we got 15 right.
15 right. 4 is still wrong.
Okay, so do we want to try?
The middle and the side?
No. Let's try, because it just says the where am I? Okay, in the beginning, right before 3, it says the null hypothesis is equal to, and then not equal to. So we didn't try the not equal to. So the two-tailed.
Oh, I see.
That's the only one. That was the other option. Uh-oh, don't freeze on me, computer. I just bought you. What? Oh. And change that to 8.
Sorry, what did we get for 15 again?
We did the not enough information.
Okay, so for the probability, I have degrees of freedom 8, and then I just did the 0.0403, and I just did two-tailed. Since in the beginning it says not equal to, so that gives me 0.9688, so 0.969. That honestly would be my only other guess.
So what did you do there?
Well, in the beginning it says, when you read, oh, wait a minute, but it says, yeah, for the following information for the next 2 questions. So for 3 and 4, but so, and it says the null hypothesis is equal to 0, and then the alternative is not equal to 0. So we're not doing greater or whatever lesser than in that little applet. We would just do two-tailed. That would be my guess. So I'm going to do 0.969.
All right, you try it. See if you're right.
Okay.
Because I don't know on this one. I'm lost.
I don't know about that one.
Well, no, I think that we just need to ignore the fact that they said it's greater than.
Yeah.
And just do.
Okay.
Here goes.
No,
I
still?
got one wrong. Which one is it? Four.
Oh, man. What is it? So maybe we just select. No, we did that before.
It says use this probability to determine the p-value. So is there an equation?
Yeah, what's the equation for p-value? Or is it, it's just, well, there's not one. It's all just putting it into the applet.
Yeah.
No, there has to be an equation.
I think
Well,
it's all in the applet.
the only thing that we haven't tried is the middle one by itself.
I don't think.
I don't think we can ignore the greater than part of it, though. I mean, that just does not make sense.
Or wait, did we do the middle and the right side already? Yeah, we did
Yeah,
do
that was the
that.
first one we did.
Yeah.
Okay. Because it was basically the same thing as the middle and the. This is stumping us. I wonder when that TA is going to come in. Probably not.
Right.
Or maybe I was thinking like there's a way she can get in and see us, but not interact
No.
with us.
I don't think that's possible.
He's super
Okay.
creepy.
Hold on, I know. Okay, the p-value is the probability of obtaining a test statistic at least as extreme when you collect. Assuming the hypothesis is true. In other words, our p-value is the probability that we would get a z-score that is extreme or more extreme than z. Oh, this is where we use the two-sided alternative hypothesis when computing the p-value. We need to continue this logic, so we would have considered a value of to be.
I'm stumped.
Wait, so are we sure that 0.0403 is the right test statistic that we're supposed to be using? Because it seems airtight, but we've already assumed that that is airtight, and that's the only other variable in this that, if changed, might make a difference.
We make it 2 because we're testing his test statistic, which we determined in question 3 to be 2.
Right, and he says, use this, or it says, use this probability to determine the p-value. So it says to use the 0.0403, but
Well, it says the tests are greater than Jordan's. So would we use 2 as the test?
But then I don't know where that 0.0403 would come in at all. Like, I don't.
To confuse us?
I don't know. That's weird.
I wonder.
So when I put 2 in as the t-score with just the right side highlighted, the area is 0.0403. That's weird.
So it's like our answer is 0.0403. I mean, they could do that to us, I guess. So
let's see here. The probability of getting a test statistic greater than Jordan's.
So
like the probability of his being higher, or the probability of getting one that's greater than Jordan's is the 0.0403. So use this probability to determine the p-value for Jordan's hypothesis test. So do we? So if the what if the 0.0403 is the probability, and we put that at the top, and then we write the t number.
Okay. Yeah, if we do that and we highlight just the right side,
It would be
Wait, but that doesn't make any sense. You're putting the 0.0403 in the top of the
right because it's saying use this probability. So I'm saying, oh, is that the probability? Because the probability, this is the probability. So it's
Then-
giving us a probability, not a t. Does that make
But
sense?
then that's where, because the area is where you're going to find your p-value. So
Okay, but the probability of obtaining a test greater than Jordan's is 4. So it's saying 0.043 is a probability. So use this to determine the p-value for Jordan's.
and the p-value is the two tails, right? Both tails. If we're going to go with his original one, right?
Determine the p-value for Jordan's hypothesis test.
I'm going to try one more. I'm going to try, so I put in 0.0403 into the top.
Okay.
I highlighted both tails. It got me 0.0805.
Okay.
I don't know if that's
0.0403. Wait. Do you have your degrees of freedom at 8?
Yeah.
And
Wait.
I got 2.4.
yeah, that's what I'm getting for my t-score. How did you how did you get what you got?
So if the t is 2.
Oh, you're using 2.
Yeah. So t
Wait.
equals 2.
How? I don't
Okay.
understand.
That changes. Well, so he used our answer that we got for number 3 rather than you and I. We just used.
If he highlights just one side of it, it's 1.99 in the T slot or the test.
So it's pretty much 2.
Right.
If you put 2 in for t, then you get the area or the probability of 0.0403.
That's just if the right side is highlighted.
Mm-hmm.
But I think the question is asking, use the probability to determine the p-value for Jordan's original hypothesis test. So I think we'd highlight both sides.
And then we would just use 0.0805 as the p-value.
Yeah. What?
Okay.
Yeah. I mean, I'm gonna.
Where do you get 0.0805?
You click on both tails.
Yeah.
I am. So I put in 0.043 in the area, and I clicked on both sides, and it gives me 2.4.
What?
So do this instead. Instead of mess around with the area, then put in 2 for t, and then the area should change automatically.
Oh. 0.08. Okay.
Yeah. Let's try it. I give up. And I think that sounds the most logical to me. So
Okay.
I have to go through and put in all my answers again. So 0.0.
Oh my gosh, I'll have to do that too. That sucks.
Well,
wait, maybe not.
If I get it wrong, then don't bother. Like, you've got as high as you can get.
%.
But really?
Yeah.
Great job.
So number 4 is 0.0805.
Did you put that whole thing in, or did you put 0.081?
I put 0.0805. That was really, really lucky. So you should probably put 0.81, but
Okay, I'll do that. I will do that.
Do that one. Yeah, and tell me what you get, Josh. I'm writing all my little answers down so I don't have to redo everything.
I don't know why it let me get that. That's crazy, but
I'm so glad though that we got that. I'm like,
I know.
that's what bothers
Wow,
me. You have that one, you're like, what?
seriously.
Yeah, that was a lot going on there.
Do you need answers or anything?
Yeah, if you just want to read them out, because I'm just kind of toggling back and forth. I'm on 7.
Okay, 7, fail to reject the null hypothesis.
Okay, 8.
8, we have insufficient evidence that the mean of the difference is greater than 0. Number 2.
So the second option.
Yeah. 9, n.
Okay.
10.001.
Okay.
11, reject the null hypothesis.
Okay.
12, decrease.
Okay.
13, reject the null hypothesis.
Okay.
14, the third one, we have sufficient evidence that there is a mean difference between the two groups.
Okay.
15, not enough information.
Got it.
16, 11.955.
Okay.
17, 6.652.
2. Okay.
18, 5.303.
Okay.
19, 18.607.
All right, let's do it. Cool.
Good job, guys. That was a good job on number 4, figuring that out.
Yeah, that was a weird one.
Oh wait, what was number 3?
2.
Oh yeah.
Do you need the answers too?
Well, I just wrote them all down. Okay,
okay.
wait. So
I'll just read them to you.
0.0805 and 0.081 both worked.
Yes.
Yeah. I don't know how.
That's
but-
funny.
That's great.
Number 5 is 0.47.
6.689. 7, failed to reject the null hypothesis. 8, the second one. 9 is n. 10 is 0.001. 11, reject the null hypothesis. 12, decrease. 13, reject the null hypothesis. 14 is the third one. And I'm sorry, but that's a typo at the end. Group. It needs to be groups. It's a math
I
teacher,
found
not an English teacher. What's that?
No, I've seen some typos, and I'm like,
Come on, man. Get your game together. No, just kidding.
Well, I mean, we're human, you know. It's
Yeah. 15, not enough information. 16, 11.955. 17, 6.652. 18, 5.303. 19, 18.607.
all right.
You know, these do take a lot of time, but I really like these group things. Like, it really helps me with this math a lot.
Yes, it helps like ingrain it, and then
Yeah.
if you have questions, there's somebody to bounce it off of, you know. And
Exactly. Like, when I took the test, you know, I studied a little bit beforehand to, like, make sure that I knew how to do everything. And then, like, when I took the test, I was like, oh, wow, yeah, I remember that one. We did that one together, you know, and I remember that one and that one.
yeah. I'm super nervous about the exam coming up.
Yeah, I'm
There's
not
another one?
next week. The end of next week, I think.
Yeah.
Dang, that's crazy. Is it I don't know, I haven't checked it, but are they going to make us take one lesson and then do the exam and then take another lesson?
I don't know.
I thought he said in something where it was going to be. I don't remember. I guess I read it as, oh, like this will be like continued over, or like, unless I misinterpreted the word. I don't remember. But the way I read it was like, oh, it's not like this next exam will only be just what we learned from the first exam to now. Like any lessons in between.
It'll just be the chunk in between. That's nice.
Because I felt like he was saying
Everything.
but that could have been like, you're going to need, now that we know, I don't know, my brain.
Like everything else is building on top of that, and so you kind of like that.
Well, not like it's going to be a big mix of questions from basically the first lesson to now. Just the information we learned in the first part, well, obviously will be needed. It's in our brain to start be doing the, for the second exam.
Right.
I got 100%. Yay.
Yeah, I definitely want to join in on their review for this one.
Mm.
Did you guys do your mid course reviews?
Yeah.
Okay. And then we're gonna have to start thinking of our design research, what we're gonna do for our project.
It's basically just like this, right? We're just taking a bunch of numbers and then putting them together.
Right, but we have to figure out what's gonna be our study. I'm like, Do we want to just collect a whole bunch of data from, like, because someone said like collecting all the data from it. I don't know. I guess I probably need some more information, but I don't know how specific he wants it. But I don't know if we want to.
I need to read through all the requirements before I start thinking about it.
Yeah,
that's true.
Like, we need to make sure how big our sample size needs to be. If we need to take multiple samples, that's a big one too.
Right.
Because based on what we're doing right now, we probably do have to take multiple samples.
Well, because then I think somebody does like one, another person does the other one, another person, like we do all do our part.
I see.
I think,
Okay.
and then
we'll figure it out.
Yeah, I mean,
we will figure it out. I'm jumping the gun.
No, it's okay. I think it's good, like, because we already know everything that we've studied right now, and so if we're just going to use that in the group, it'll be easy because then we'll be like, okay, I know what I'm doing in this section, and then we just compile it all together, and it'll go really easy. So
okay, very good.
Nice work today. That was.
I'm so glad we got number 4. Like,
I know.
I have a really hard time getting 9 out of 10 or getting a 90%.
Yeah.
It's just.
I love that.
I'm at the point where I'm just like, I'm totally cool with it as long as I'm passing the class. That's all.
Right. That was my attitude. I was like, I'll get a C. I'm happy with that. But this is my only class, and I haven't been at school for a while, and I'm pregnant, and I guess I want to. I guess I'm fearful that on the exam or one of the exams I'm gonna do like bad. I don't think I will, but
no, you won't. It's just your mind tricking you into thinking something bad. It's the devil. He's whispering in your ear, "You're gonna do really bad." So you'll do fine.
No way. I have a protection.
That's
right. I have
right.
a baby.
That's right. I forgot about that.
I want to stop the broadcast before we